Hey everybody, this is Michael from Barton Musical Circuits, and this is the new dual AR generator. I'm going to try to do a circuit explanation video for this. This is similar to what I write in my documentation, but it might be easier for people who learn by video. And this is one that has kind of different phases going around with it, so it might be a little bit easier to demonstrate this visually. So yeah, this is two channels. We're just going to go through one channel. The two channels are identical. But yeah, let me zoom in and we will start. Ooh, that was a zoom out. We're going to start over at the end. Let me double check that that is all on screen. Yeah, beautiful. Okay. So the inputs, G1 and T1, gate, trigger. The difference between these two is trigger goes through this capacitor. The capacitor and this resistor is our pull-down resistor, so that's going to keep this at 0 volts when there's nothing in, but it also forms a high-pass filter with T1. So the comparator, instead of seeing a gate like this through T1, it's instead going to see just a little positive pulse, and then it goes to ground, and then a negative pulse, and then it goes back to ground, and then positive pulse, like that. And it's going to ignore those negative pulses because we've set our threshold here with this 100K and 1K to be 12 divided by 100. So that's, I believe, 0.12 volts. So whenever an input here goes over 0.12 volts, that is going to make this comparator change from a positive output to a negative output. See, we're going to the negative input, and the threshold is on the positive, so this is an inverting comparator. So gate goes high, this output goes low. And with the gate, it's going to stay low until this gate goes down, and that's going to be important because this AR generator is one that has the envelope where envelope goes up and stays high until the gate goes low and then goes back down. It's also one that's set up that while the attack phase is going, it's going to ignore any new gate or trigger inputs until that's done. And the reason I've done that is because I like it. It divides the inputs and it lets you get these interesting kind of clock dividing sounds to your music. But yeah, so we know how that works. That is going to go to our second op amp, which is the most complicated part of the circuit. So we've got negative voltages coming here. This diode is only going to allow voltages that are less than ground to go through. This 100K to ground is grounding this pin, and this 1K is just barely dividing down a little bit of the input signal here. And then here we've got this diode that is only going to allow positive voltages to feed back from our output buffer. And this is going through a 10K resistor. Now, some of you might notice that 10 is a bigger number than 1. What this means is that in a situation where both of these outputs were at their maximum, it would be a slightly more negative output than positive. And we do this so that in a situation where they are competing, we're not going to change phase and go into decay early. We're going to have the gate control things instead of the output buffer. Which this is a really cyclical circuit, so I'm kind of talking about something that I haven't explained yet. When the input is low, there's not going to be any negative voltage coming from here. So then the positive voltage from here can take over, and this input to this Schmidt trigger, or comparator with hysteresis, this op amp, it can go as high as it needs to, which should be high enough to hit the positive voltage threshold to change the phase. So let me explain what that means. This op amp is wired as a Schmidt trigger, like I said a second ago. And so what that means is that instead of having just a single voltage threshold point like we had on the input comparator, this one goes up and down depending on the output. So when our output is high and there's positive voltage coming from pin 7, that's going to feed back to the threshold through this 100K resistor. And then these other two resistors are going to divide that voltage down, this 100K. So if we ignored this one, 100K, 100K, it's going to halve it. So you would have a threshold that changes between plus 6 volts when the voltage is high on the output to minus 6 volts when the voltage is low. And like our input comparator, this is also wired with the input on the negative terminal. So this is inverting. So we need a very positive voltage here to make the output go low and a very negative voltage for it to go high, which that's why we're sending negative voltages from our input comparator, is we want negative voltages to send this high. But yeah, we do have this 120K resistor, which I told you to ignore. And what that's doing is it's applying a positive offset to this threshold. So instead of being from +6 to -6, it's instead going to be from a little under +12 to a little -0. We see it's 120K instead of 100K, so it's not applying as much of an offset as it could. I think the actual voltages when I measured were, I think, -1 and +8, something like that. And I've been saying goes +12, goes -12. I'm talking about if these were ideal op amps. I usually design like the op amps work perfectly, and then I deal with the consequences later. So let me summarize what we've talked about so far. When you first turn this module on, this is going to be at 0 volts. You're going to input a gate, and that's going to send this negative voltage through here, which is then going to send this output positive. It's going to change the threshold here to be more positive. Eventually, the output voltage is going to rise, which we'll cover how it does that in a second, and that goes through this 10K resistor back down here. If the gate is still on, that is going to be ignored. Once the gate goes down, it's then going to look to see if that output voltage is high enough to hit the positive threshold, and then change the output of this comparator so it's now sending out negative voltages. It going positive to negative, what does that actually do? Let's take a look at that. So for a second, let's ignore all of this, and let's just look at charging the capacitor. When it has a positive output, this diode is going to allow current to flow through this 1K resistor and this 500K pot to charge this timing capacitor here. Now we actually have 2 timing capacitors, one of which can be switched in and out of the circuit to have a slow mode. A bigger capacitor is going to take longer to charge and make the circuit go slower. But yeah, we are adjusting the resistance to adjust how much current can flow through and how quickly that capacitor is going to charge up. Capacitor is then being buffered by this op amp, sent back to our Schmidt trigger, and then sent to the output through a voltage divider to make it close to the 0 to 5 volt range, and then this 10K to an LED to give us a visual indicator. And then when we're also in the attack phase, this diode down here is going to be sending plus 12 volts to this 2K resistor and this diode here. And what that is going to do is it's going to be making it so this diode does not pass any current through this 2K resistor to ground, through the release pot, when we're in the attack phase. And initially I didn't have this, and when you set the release very, very low, it would actually adjust the attack. You wouldn't have your attack reach the peak because so much current was being bled off to ground during the attack phase. During the attack phase, what we have is we're going to have a positive voltage over here. This will be a higher voltage than we have on the cap, and so this diode is not going to be able to pass any current from the cap down to ground. But during the release phase, this is going to be a negative output through the Schmidt trigger, and so this will go back down to 0 at this point, and then we can start bleeding current off of the cap through this resistance formed by the pot and the resistor down to ground. That is basically how the circuit works. If you wanted to tweak this circuit, the easiest places to tweak it would be the timing capacitors. If you wanted to have really snappy control over very fast attacks, you could lower this to a 0.1 instead of a 1 UF. You could also increase the 22 to a 47 or 100 if you wanted super duper duper slow. And then the 2.2K and the 1K resistors, these are adjusting the minimum time for release and attack, so you could adjust these as well. But yeah, thank you for watching this. Hopefully this was more helpful than if I hadn't made the video. Thank you very much.